This is the world's first digital camera from 1978. Any ideas which company might have been behind that? Yeah, that's right, Kodak. Most famous kind of for having then subsequently missed out on the whole move towards digital and then having come and caught up. I can tell you, you see the tape cassette and stuff there. It took us quite some time to get Elixir up and running on this. I am going to talk just a little bit about our company, what we were building, the technical decisions that we went through, and where that led us to. I'm not a developer. I'm sorry, but Miloš will be up in about 5 or 6 minutes, and he actually is the guy who did all the work in terms of Elixir. So I'm telling two stories basically. One is the evolution of our company, and then the technical decisions that basically I was kind of responsible for during that time. So I hope you can handle two stories in parallel, but as functional programmers, I think that shouldn't be a problem. If I take this sort of from the beginning of the story of building our software, so this is more or less the view from my apartment in Berlin, and there was this social gardening project going on, and there was an architectural project, and I wanted to make a time-lapse movie. So I wanted to grab JPEGs from 2 cameras and turn it into a video and make a little video over about a year to watch what was going on. And I got in touch with a friend of mine, a developer, and he put something together, really, really nice, really quick. He's a C#.NET developer. And so we started building this time-lapse, and it was lovely. And I said to him, hey, listen, why don't we speed that up a little bit? Let's take a picture every second and see what happens. And so with the 2 cameras there, he did, and it kind of worked, and I could see, this is kind of nice, this is kind of interesting. We had the bones of what looked like a cloud CCTV, where you had the camera, and it was bringing back the images back to the data center, and you could log in and you could see it. So I sort of took my approach to this. I made a little website and said, cloud CCTV, come and get it. And about a week later, I got a call from Singapore Telecom saying that they had 1 million customers on fiber optic, and they were interested in rolling out a cloud CCTV platform to offer like home security as a service. So I said, yep, no problem. I'll get Victor on that. That's exactly what we do. And yeah, right. This is the slide that summarizes the 3 years after that. It was a tough old journey. We built up another team of developers around it. We had some guys in Pakistan, and we stayed on the C#.NET platform. We just uncovered a world of problems dealing with all these different types of hardware. Every camera was different. It's a real proprietary industry, the security industry, which frankly neither of us knew anything about. All the codecs, as you know, in the world of video are all sort of like different and complicated, and then you have the extra difficulty of bringing this stuff over broadband. So just a world of problems. And on top of that, we never got Singapore Telecom as a customer. So we did get some other kind of like significant customers, but it never really worked out as a business, to kind of leave that story aside. I did get another phone call that was interesting, and this time it was from a company called NetSuite, who make basically cloud accountancy software. And they said, hey, listen, I don't want your security system, but what I'd love is to get a JPEG and attach it to every document that comes through our system, kind of like a signature to just verify the event, so we could actually just see the thing happening, the person doing the delivery or collecting it or buying it or whatever it is. I thought, gee, wow, that makes sense. This is it. Suddenly, like all the problems that we've solved, all dealing with all the different bits of hardware, having this beautiful like cloud interface, it all comes together, but I didn't have the problem of storing all of these images. So they said, do you have an API? And I said, yeah. And then I went and Googled, what is an API? Yeah, that's how it goes behind the scenes at the top. And so I thought, this really makes sense. This is great. We're going to be the developer platform for cameras. And I don't know if you're familiar with a company like Twilio, and these other like big API companies that have really been making it in the sort of the developer tools scene. The only thing is my kind of rubber neck would only carry me so far, and I kind of knew that between myself and the guys who I'd built the software with so far, we weren't going to fool the developer community. And if we were really going to be serious about building something that developers were going to use, it was going to have to be a lot more solid and also presented in a more developer-friendly way. So kind of looking at the problem, I kind of knew that the people I wanted, I was more likely to find them in the open source world and in the open source community. And I didn't know a whole lot about it, and I was asking around for advice, but I kind of knew that's the way it was going to be. So I started a new development team based in Dublin, which is where the company was based then, and hired some guys who were sort of familiar with more of the current trends of software development. And they looked at the problem, we talked it through. I knew a lot about cameras from a sort of, we'd been through a lot of the rubbish, but I wasn't particularly technically strong. So we said, okay, let's go for Ruby as the platform. It's been around for a while. This seems sensible. So we started to build another system in parallel in Ruby, and look, the initial progress was good. And we started transferring cameras from our old system over to the new system, and pretty soon we kind of realized that, the task we have of like having all of these different processes talking to all these different cameras isn't particularly well suited to Ruby. So Tilmac, one of the guys working with us, he said, listen here, Node.js, I think this is the way forward for this, and we'll have a go at that. So he took that part of our system and rewrote it in Node.js. And round about, here comes the third story in parallel, round about this time, I started working on another sort of related side project with Miloš, and he was building that out. And what I noticed is that Miloš was a great guy to work with, was making great progress, and was actually the person who I probably wanted in as lead of this bigger thing, the main event, Evercam. So long and the short of it is, Miloš was over in December, just December of last year, and we're talking through the plan for the year and so on. And he says, Marco, listen, I've got this idea, Elixir. I've been reading about this new language. I think it could be exactly what we need. I see some problems with Node.js. I'll let him talk you through that sort of side of things. And I was just terrified. It's like the last thing I wanted to hear. Some weird language that I'd never heard of. And we're going to build this thing for the 4th time. But there's one thing that I really knew strongly is that I wanted to work with Miloš, and also that he's not the kind of guy who makes decisions from a sort of an egocentric point of view. I knew he's a thoughtful guy. He put a lot of thought into this, and he was able to let me see that, basically, that he genuinely thought this was going to be the way forwards for us. So I made a deal with him, and I said, okay, there's a speaker conference on in Krakow in about 4 months' time. Tell you what, we'll go for Elixir, but at that conference, you're going to announce to the world the wonderful product that you have made on this new language, and that gives us like a time frame for this. And poor Miloš wasn't very keen, but it shows how much I think he wanted to use the language that he was prepared to make that deal, which brings us pretty much to today. There's one other aspect to the story that I think is worth telling, which was as we moved from the sort of the Microsoft world to the open source world, I got exposed to the sort of the ideas behind open source, the open source community, things like GitHub, the working processes behind open source, and I saw that it really worked for us. It worked for us just from a technical point of view. It worked for us from the sort of people that I wanted to be working with, and it also worked from the values point of view. We were working with cameras, right? And the cameras is dominated by the security industry, but that's myself and my business partner. We don't really have that security industry mentality, which is very locked down, closed circuit. We're all about sharing of information, transparency, and so on, so on. So we just got very keen on that, and ultimately we made a decision 2 weeks ago where we said, hang on a minute, let's just open source the entire thing, everything we're doing, and have this developed as part of the open source community, which is, in hindsight, perfect for the problem we're solving, which is a problem that is really composed of about 10,000 small problems, hence, you know, that guy with all the knives through him. It really is, it's just a case of all these little modular problems that need to be handled. So, over the last couple of days, I've been sort of quite liberally just flicking the switch on GitHub and going live with these repos, which there's a big disclaimer over. These are not yet really fit for public consumption, but you know, I'm trying to get them all live before the next $50 a month bill comes up sometime in the next couple of days. Right, so that's kind of the human story of what, or the managerial perspective story of what got us onto Elixir, the decision that, you know, I'm really, really happy with, but it was a decision mostly made around people, and the people I wanted to work with, and the people I wanted to align our business with. Miloš can probably give you a more insightful description from a technical point of view. Thank you.
So, I'm Miloš Mošić. I'm lead developer and slash CTO of Evercam. That's me on the left. On the right is it's my girlfriend. We are the couple behind No Melon, and we work with experimental stuff. Like for me, doing weird technologies, and for her, it's visual design. So CTO in my title actually means change technologies often, because it's the fourth time we're changing the company strategy regarding to technology. So when I joined Evercam, we actually had a somewhat working solution. We had an API in Ruby. The dashboard was in Ruby 2, and it was a pure API client built in Ruby on Rails. And the only thing that was kind of separated was the Node.js, which communicated with cameras, sending the actual request to them at rates of thousands per second, which wasn't something that Ruby was made to do, obviously. So that actually worked mostly fine. And if someone looked at the code and looked at what we did, he would be confused about why is there why am I trying to move from Node.js? Node.js is web scale, right? So it surely can provide us everything we need from scalability, fault tolerance, and concurrency is a big thing. But actually, turns out that the thing that we built in Node.js was the perfect thing for it. It was really heavy on I/O. There were a lot of requests coming in and out, but it was both unstable and hard to maintain. In the few months that we had our Node.js server running, multiple NPM modules were either outdated or had security issues, or we had to pick up the ball and patch them ourselves. So it wasn't. That is, I had to do it. So it wasn't a nice thing to work on. It seemed like most of the work was going into making it just continuing to work. And even though it's web scale, one thing that Marco mentioned about cameras that differs our business from other web-oriented businesses is the web stuff is only only the front-facing part. The actual part, communicating with cameras is much more important, and it should be, well, all the things you know about Erlang. It should be fault tolerant, it should be highly concurrent, and it should be, first of all, reliable. Like, people use our systems for security measures, and it's a high priority for that not to go down. And there's one running joke in Erlang community that I saw is, you never hear about telecom provider calling you and saying, oh, our systems are going to go into downtime like this weekend, so don't use the phone, because they're using technologies and they're relying upon systems which had decades of work that went into them to enable them to run all the time with high reliability. So if Node.js has this done in their community, I think the appropriate one for Elixir is utility scale. That's especially for our business, because one of the goals we have, one of the long-term goals for us isn't just having those security cameras that are connected to home systems and maybe private businesses and so on, but actually connecting all the public cameras available in the world as a sort of a public utility function. So to be able to handle that, you need to know that that technology is highly performant and will stay here for the next 5 or 10 years or more. We're not making something that is a quick hack just so like we make something that makes money and that's it. As I said, the original system worked kind of fine, but I was really interested in making it better, even if that means rewriting major parts of it, or even in my own time, because I was so involved in getting a better system out of it. So I looked into various new, well, kind of new to me programming languages, and I looked into Scala, Go, Clojure, and Erlang. So one thing I realized when I looked at various languages is that even though, for example, in Scala there are actors and there are many. It had Scala and Arca together have many features that we would need and that mirror some of the features in Erlang. But I realized if I went that route, for example, I would end up re-implementing whole parts of OTP on my own, which isn't like the smartest thing to do. I would much rather rely on decades of engineering that went into Erlang and OTP and not reinvent anything myself, if I can choose. So that was actually the decision that led to using Erlang. Like, it wasn't a crazy idea. Even though it sounds like that, if you're not familiar with the language, but the Elixir was a completely new thing to me. I heard about Erlang, Elixir, maybe on some post on Hacker News or something, but I completely missed it. While I was looking at Erlang, I saw Elixir, and it was at I think 0.12 or 13, so it wasn't really stable yet. And I was I was very into jumping into Elixir, and like because I always had that idea of talking to Marco and selling him the idea of, oh, we will just switch to this new technology that's not even 1.0, and it is going to be much better than what we already have. So that wasn't really an option. So that process of looking into new technologies and thinking about this, our perfect system took. I spent a couple of weeks on it, and the the definitive moment when for choosing Erlang and Elixir was when I stopped looking at the languages and then tried to imagine what would I like that system to be. Like, what do I need? I need to be highly concurrent. I need to be fault tolerant. I need many processes. Ideally, I would have one process per camera, and each process should be supervised, should be automatically restarted, should be running for a long time, possibly infinite, and well, a couple more things. But turns out that all of those things are available if you use Elixir and OTP. Okay. So, or I can switch. Previously we used Psychic for background processing for simple things like sending emails and also like getting the snapshots, the recordings for the cameras into our system. And that's the one important bit. One important thing for me while building the Elixir part of the system was to make it so it's external to our current system. So if something goes wrong or we decide not to use it, I can just replace it. Well, shamefully, but and because we were using Sidekick already, I came to the idea of using it as a message, like sort of a message queue. So Sidekick stands upon the API, and it will just communicate with the Elixir server over Redis, like just exchange processes. And it turns out that that was one of the things that Chris McCord, creator of Phoenix, mentioned several times, and Benjamin Tao, one guy, blogged about it, and he had the same exact idea. Like, let's just use Sidekick from Ruby, and the Ruby server is completely unaware that there's an Elixir server external to it. It just gets the computer jobs from it. So this was like a side step. So this is kind of how our supervision tree looks right now. We have our application supervisor. There's EXQ, which is it's basically Sidekick implemented in Elixir. I actually thought about just putting stuff in Redis directly, but I found EXQ and it was really easy to just start to use. And the worker supervisor supervises the cameras, and each camera has its own camera worker, which is process supervised with infinite restarts, and each process has its own child processes, which are which do the recording of snapshots, and in the future also video. For now, we are just getting the JPEGs because that's the feature that most of our cameras have. Worker supervisor is he has a strategy simple 1-for-1. now, which makes it really easy to dynamically add camera workers when when we add new cameras to the system or remove them. Like each camera worker is exactly the same. The spec is exactly the same. So that's it. And this is kind of there's line missing, but this is kind of our technology stack before and after transition to Elixir. This is not fully complete. We're still using Pusher on the dashboard, but we'll be transitioning to using WebSockets via Phoenix, because it makes it really easy to just pass on the data from the running processes in camera worker to Phoenix channels. And this is kind of stolen from Sasha Yorich's book, Elixir and OTP in Action, which has many patterns for using Elixir and OTP. Okay, I'm going to jump into that. So this is just an example of code we are using to generate versions for before actual deployment. It's very simple. It uses Git tags from Git and then also the SHA for the actual commit. So we use this before we had deploys to Heroku, just git push, nothing special, and also Capistrano. For Elixir server, I opted into using Ansible, which is a configuration management and also deployment tool. So what I do before every deploy is I use rolling releases. A rolling release is a way to bundle the application, all the dependencies, and the actual virtual machine into one package and deploy it on the server, which would run it without having Erlang or anything else installed previously, which is handy, but that's not the selling point. The big thing for me for using releases was hot code reload. In Ruby, we always had to deal with the short downtime between switching to the new versions of the application. So what we did was use basically rolling releases with Unicode. On Node.js, we had a load balancer, and then it's the same thing. So it's a rolling release. 3 servers, one gets updated after the other. But for Elixir, we use XRM, which is Elixir release management tool, and what it gives you is it extends the mix tool with the command mix release, and then you can just do next slide. You can just get the dependencies, compile, and make a release. One tricky thing there is that you have to have you should have the previous version of the Elixir or Erlang application, so you can get the upgrade. So what I'm doing in Ansible is I check what the running version of the application on the server is. I check out that commit, of course, get the dependencies and make a release, and then I do the checkout to the version of the application that I want to deploy. So this is like the last commit on the master branch. And then I make another release. So what this does is it enables XRM to create AppUp files and relap, I'm not sure about the pronunciation, which is, you can think of it kind of as a diff between two states of the application. So when you put the new release onto the server, it can see what code changed and change it like without any downtime or even without any dropped network connections. It just automatically works. There are a couple of bad things that I experienced while working with Elixir as someone who was completely new to the whole world of Erlang and OTP, and that is, from my point of view, Erlang knowledge, at least the basic Erlang knowledge, is kind of required. If you want to do anything more advanced than what you can actually get in Elixir guides. I also had a couple of situations where I had to dive into Erlang's source code for some libraries that didn't behave the way I expected them to be. So, because I didn't have any Erlang knowledge, and it was faster for me to just re-implement it in Elixir, which I think is a shame. I would much rather rely upon Erlang libraries that are proven to be stable. And the good things about it, there are of course plenty of it, but one thing I haven't seen mentioned often is, one thing that I wanted to mention is specifically with Phoenix. I really enjoyed the upgrade guides, which make it really easy to just continue using the pre 1.0 releases. We started with, because I started this as a side project, I started using Phoenix at 0.4, and now our application is, I think, 0.10. And I just did every upgrade manually, and it all worked fine. It was pretty painful. Oh, painless. So, not specific to Elixir, but it kind of overlapped with my switch to using Emacs, and specifically Spacemacs, which is, I think, I would recommend to everyone to try it. It's basically Vim plus Emacs, which is a heresy, but also it reminds me of Phoenix because it's so well run, and it has many contributors, and it has a clear vision of what what it wants to achieve. So it's basically using space as a guide key in Evo mode in Emacs, but there's much more upon it. There's specific layers of functionality specific to the language, like for Clojure or for Elixir. There's a separate layer that you can just enable. And of course, I should mention Alchemist, which is an Emacs mode built for using with Elixir, and it enables you to do real nice stuff like running the test for the current module automatically. It has auto completion. You can drop down to IEX from Emacs editor and like test your code. So these two things really improved my boot speed, and like it made it much easier to develop with Elixir. So, like Mark mentioned, all of our code, most of our code is open source, and in the end, pretty soon everything will be open source. So it's on github.com/Evercam. And the other link I have here is Mark Mias, if I haven't butchered the name. he actually made a wrapper in Elixir for our API. And he did it even before we actually open sourced everything in Elixir. So that was great. And okay. So yeah, that's it. And aside from the conference-driven development that I practiced in the last couple of months, I hoped also for Jose-driven development, which is like, should I just put some code on the slide and let Jose like improve it? But because everything is open source now, I think if you see something that we did wrong or like a better thing to do it, like even issues are welcome, not just pull requests. So feel free to contact us on it. And that's it, basically. Questions?
Any questions? Hi, so you, yes. You mentioned that you have like camera worker, one camera worker per camera.
Yeah.
So what kind of numbers are we talking? And
What kind?
what kind of numbers are we talking?
Oh, so currently it's about 3,000 processes. So we have one supervisor which has 3,000 child processes, and each of them has multiple processes. So it's in the range of 10,000, I guess.
Okay. It's one VM, right? It's one VM.
Yeah. One of the first tests that I did when evaluating the Elixir was how many processes can I actually run on my machine, and it was like in order of like almost 10 million. So it was really impressive. Like what we are doing with it, like it's not even touching the limit.
Any other questions?